Let f of xy equals to xy into x square minus y square upon x square plus y square, where xy not equals to 0, 0. For f of 0, 0 equals to 0, show that f of xy 0, 0 not equals to f of yx 0, 0. Solution: we have f of xy 0, 0 equals to limit k tends to 0 f of x 0 plus 0, 0 plus k minus f of x 0, 0 upon k. Now f of x 0 k equals to limit h tend to 0 f of 0 plus h k minus f of 0 k upon h equals to limit h tend to 0 h k into h square minus k square upon h square plus k square minus 0 upon h equals to limit h tend to 0 k into h square minus k square upon h square plus k square equals to k into 0 minus k square upon 0 plus k square. So f of x 0 k equals to minus k. Equation 2. Also f of x 0, 0 equals to limit h tends to 0 f of 0 plus h 0 minus f of 0, 0 upon h equals to limit h tends to 0 0 minus 0 upon h. So f of y 0, 0 equals to 0. Equation 3. From 1 and 2 and 3 we get f of xy 0, 0 equals to limit k tends to 0 minus k minus 0 upon k equals to minus 1. Again f of yx 0, 0 equals to limit h tend to 0 f of y 0 plus h 0 minus f of y 0, 0 upon h. Equation 4. Now f of y h 0 equals to limit k tends to 0 f of h 0 plus k minus f of h 0 upon k equals to limit k tends to 0 h of k into h square minus k square upon h square plus k square minus 0 upon k equals to limit k tends to 0 h into h square minus k square upon h square plus k square equals to h into h square minus 0 upon h square plus 0. So f of y equal h0 equals to h. Equation 5. Also f of y 0, 0 equals to limit k tend to 0 f of 0, 0 plus k minus f of 0 upon k equals to limit 0 minus 0 upon k. So f of y 0, 0 equals to 0. From 4, 5 and 6 we get f of yx 0, 0 equals to limit h tend to 0 h minus 0 upon h equals to 1. So f of xy 0, 0 equals to minus 1 f of yx 0, 0 equals to 1. So which implies f of xy 0, 0 not equals to f of yx 0, 0.